Dr. Stephen Law is a research fellow at the Alan Turing Institute and senior research fellow at University College London, Bartlett School of Architecture. His current research interests lie at the confluence of machine learning, urban analytics, and real estate analysis. He completed a PhD at UCL studying the economic value of spatial networks in the housing market, a master degree in urban design, and a bachelor degree in economics. He has over 10 years of international consultancy experience, including Space Syntax Limited and ACOM, with emphasis on pedestrian movement modeling and simulation, geospatial analysis, network science, and urban design. So it's a pleasure to have you here, Stephen, and thank you very much for your presentation.
Thank you, Abel, and it's an honor to come to give a presentation here, and especially after such a wonderful talk from Kate. So today my talk is about outlooks and challenges in urban design and data science, machine in the urban design loop. So this is very much a speculative kind of talk, rather than like a talk only about my papers, but most of the research is actually kind of like what I see in data science and how I see it can be embedded into urban design. So we're living in an age where we have an abundance of data and scientific methods. The question I have is, how can we use this knowledge responsibly in designing better cities? So I came up with this concept, kind of inspired from a conversation I had with a friend, of like, how can data science and machine learning methods embed into like the typical urban design process? So the typical urban design process consists of like context analysis, site analysis, design developments, and design and evaluation, which will often be like in like a loop where you would need to repeatedly have this kind of developments and analysis until you get to some sort of compromise between the constraints you have of the environments and also as a solution for all the stakeholders. So like my idea here, what I call machine in the urban design loop, is basically I was thinking about, okay, I learned a lot of data science methods in the last couple of years. How can each of these methods get embedded into different parts of this urban design process? So now I'll talk about like four of these four of these kind of topics. The first topic is I call the discovery, which is the part which is after the context analysis, where I was asking, are there some data science and machine learning methods we can use to discover information from the urban environment? So the first case study I will explain is the kind of using unsupervised clustering, which is a type of clustering methods you apply on like a data set to retrieve like natural clusters. So in this case, if you apply it on socioeconomic data, you actually identify what they call geodemographic clusters. So as an urban designer, this can be a really important layer in your design, because then you'll be like, then you know who is living in different parts of London. And with this in mind, you can help you to make a more informed decision. So this is a paper from Alex and Paul, which they basically mapped out the different kind of lifestyle areas in the city of London in different parts. And if you're designing for a specific area, you should try to respond to this kind of layer. So the second case study that I'll talk about is about opinion mining. So this is a paper from Hu et al. In 2019, where they developed a web blog to ask people to write reviews of the different parts of areas of New York. So using analysis such as natural language processing to basically find out where are people basically happier and where are people basically less happy. So, and in terms of different topics for the different areas of New York. And you can see on the right here, these are like the middle one is like a general sentiments people have in New York. And then they this aggregated into different topics. For example, where like the darker colors are basically where they're less happy, and the lighter colors where they are happy. And in this case, they're less happy, like in generally talking about employment opportunities, and they're happier when they're talking about like cultural diversity. Again, retrieving this kind of sentiments is also really useful in this like early phase in urban design, because you can then know what people are thinking in different parts of the neighborhood while using this kind of like natural language processing methods on kind of opinion mining. So the third case study is on using like network analysis. In this case, using like space syntax kind of street network analysis, you could then like compute over the whole city. Again, this would be another layers of information that you can use when you're designing cities. So the map on the right here is basically different kinds of between centrality, which is basically one of them uses like metric distance, the other uses angular distance, and another uses like different kinds of angular distance, like this kind of like what I called an exploratory approach, an exploratory angular distance, which is basically trying to, at every step in time, you are actually calculating the shortest angular path to your destination, but not a global kind of metric, but more of a like a local kind of exploratory metric. So this kind of analysis has been used a lot in the last like many years in urban design. And again, I think it becomes a really important toolbox for urban designer to use in the design process. And then there's also a lot of spatial network analysis you can use in the urban design process, and not just exclusive to like computing centrality, which you might be more familiar with. You can also compute things like community detection, which is basically finding like natural communities using just the topologies of the graph. So in this case, this was a case study in Nicosia, where Nicosia is like famously separated into two, a Turkish built-up area and a Greek built-up area. So using just the topology of the graph, you can actually retrieve kind of like natural neighborhoods that corresponds to how people are using these places. So this is some methods I also recommend people could be using in the urban design process. And then next is some more recent research that I was doing at the Turing, which were using like neural network methods to retrieve information from street imagery. So in this case, we're basically retrieving like the quality of the street frontage you have from like Google Street View images. So basically identifying whether the facade has blank frontages or whether the facade has active frontages. And this kind of model, we achieve like an 88 to 93% accuracy into like basically categorizing whether the street has active or inactive frontage in those 4 categories. And this is again really useful from a discovery perspective. It adds another layer in the urban design process, because then you know that if you're designing, for example, in the areas near Isles of Dogs, you know that there's a lot of blank frontages, and maybe this is something you should consider in the design process. And I've also like used these similar methods to find like more ornate streets and less ornate streets. And I've also used similar methods to basically, in this case, using semantic segmentation to retrieve like rather like how much of the street is like has tree pixels, has building pixels, has sky pixels, has road pixels. So these kind of like deep learning methods are again really useful for an urban designer to basically retrieve information that can help you in part of the urban design process. So the next topic that I will talk about is so after the context analysis, where you have like a lot of information, you discover a lot of information from your context, and just using these data science methods, you have these different layers. The next part is site analysis. And in this site analysis, I would like to talk about like 2 additional data science techniques that you can use in terms of reconstruction. The first is 3D point cloud modeling. So this is like a short video from like Uber, where they basically capture like 3D information in streets using like LiDAR cameras. And I think these techniques was used a lot in autonomous vehicles, and it's really useful because you can basically track where people and cars and objects are moving. But I think this can also be used from an more of an urban design perspective as well. So recently there has been a lot of like reality capture using like mobile phones. So like these 2 images on the left is what I captured with just my mobile phones of like very detailed LiDAR scans. And by using these kind of like mobile reality captures, you can actually capture the environment in a very high detail, which you can then apply similar kind of like knowledge discovery on these kind of data sets as well, and reconstruct the actual area in 3D. So this, I think, is going to be, there's a lot of research going on in this field, also in data science, where, for example, you can apply like semantic segmentation in the LiDAR data to basically classify the 3D point clouds as well. And now I'll talk a little bit about neural rendering. So this is kind of like really recent methods in machine learning that basically renders using neural networks. So in this case, like this method called NERV basically takes in some images from different point of view, and it can, based on the direction where you're standing at, it can kind of predict the kind of like your basically your 3D geometry and your like lights and your luminosity and the density of each pixel. So basically, in short, you can actually reconstruct a 3D model from just the images surrounding it using this kind of neural rendering techniques. So these kind of techniques has been around for a while, but NERV has really like been really popular into doing this kind of neural rendering. So to give you an example of this was like neural rendering in the field, in the wild, where basically Google basically combined all the tourist images and then to reconstruct kind of like this kind of neural rendering. And the cool thing is they actually can capture it in different luminosity and different light conditions. So you can recreate like a rendering of an environment just using actually tourist photos. So again, I think this can be really useful for an urban design context because there are a lot of images around, and you can reconstruct these environments almost live. So that was the second topic that I was wanting to talk about in this urban design loop. The third topic I want to talk about is after you have done this context analysis and site analysis, you go down into like design developments. So what kind of machine learning or data science techniques can help in the generative process? So the first method, the first kind of case study I would like to talk about in this topic is using generative adversarial networks. So maybe a lot of you are very familiar with these kind of methods, but basically they are a bunch of, they are basically a neural network architecture made out of generators and discriminators that allows you to construct really realistic images of like, if you've seen of like these deep fakes and these kind of like synthetic images, they're basically using this kind of architecture. So recently, this works has also been used in architecture. So this is some works by Chai Lo in I believe in Harvard 2 years ago called Archigan. So they basically, the input would be like a shape of a building, and then they can predict for you basically the layout of the building. So this is again a really nice method, also could be applied into urban design. He went a little bit further where he wasn't just predicting, where you give him a floor print, it also predicts both the partitions of the buildings, but also the furniture layout. So he went So he used what they called a pix-to-pix model, which is like an image translation model, like using a GAN architecture that basically translates a building into this kind of like layouts, and from the layout to giving you this kind of furniture kind of design. So I've also been doing some works with generative adversarial networks. So in my case, I try to apply in the context of counterfactuals, which are sets of techniques to produce like new like scenarios from these GANs. So instead of creating like, I don't know, generating street images that are not in reality, I try to use this real street images and try to perturb it using these counterfactual methods on the GANs to create basically counterfactuals of the original street scene and try to keep things constant. And so in this case, this is a Turing grant that I work on with some colleagues at the Turing, where I create these kind of urban counterfactuals, I call, where you can increase, say, for example, the number of tree pixels, you can increase the house price, you can increase the ornateness. What would happen to these street scenes? So as almost like a design generative kind of methods, both to really to better understand these methods and models in terms of like explainable AI, but also as a design kind of like protocol. And so more recently, so a problem with GANs is people do not draw or people do not paint in the same way as because people do not paint with pixels. So recently there has been research in the field of neural painting, which is basically the field where they, instead of using pixels to paint, they're using actually brush strokes, like primitive brush strokes to paint. So in this research from Tian in Google in Japan, they were basically recreating these arts in Japanese characters, basically using a reinforcement learning agent in these kind of neural painting methods. So again, I think this is a really, like, reinforcement learning is a really popular method that became popularized from like DeepMind of use of playing chess, but you can also apply in arts. And I think it has a lot of potential also in urban design. So I give you an example here. So this was a recent paper from Han in 2020 that uses these kind of reinforcement learning agents. So rather than paint, to actually design a master plan. So they called it, it's almost like a reinforcement learning urban designer. So instead of, like, I don't know, painting a painting, for them, they're actually using these agents to produce master plans. So in this case, you can generate many scenarios from this reinforcement learning agent that tries to, that would have a reward function, which is related to like how much this, according to some metric. And then the reinforcement learning agent would basically be placing buildings until it reaches a desirable scenario. So this is, again, using like these data science methods in the generative topics. And finally, in the more predictive, in the last and the final like process in the urban design kind of loop is a design evaluation. And in this case, I've like identified like two kinds of methods that ones can use data science methods in the kind of a predictive kind of like way. So this is a paper that I've written, I think 2 years ago with some colleagues at the Turing, where I use like housing attributes and street and satellite images to predict house price. And in this paper, I basically use a convolutional neural network, compress that into some latent vector, and then using that in combination with the housing attribute to kind of predict house price in a more traditional hedonic house price framework. So in this case, we were able to achieve pretty good results into predicting house price using these kind of attributes. And of course, using images, it improves because these are additional features that you can people should that you can use in predicting house price. But again, as an urban designer, I think this kind of model can be used in the urban design process. For example, after you have design, can you use these methods to like predict house price as a way, as an evaluation metric, perhaps in your your design process? And again, this is using these data science methods directly in an urban design scenario, in this case, using house price as a metric to as an evaluation metric. And secondly, and this includes all the other kind of metrics I mentioned earlier, like ornateness or like the frontage quality. All of that can become part of the evaluation metric when you are as part of this design process. And of course, like more traditionally, there are also agent-based modeling, to model environments and using the outputs of agent-based modeling to evaluate urban design. This has been done a lot in the last 20 or so years. And for example, the one on the right is using the kind of space and text kind of agents, using natural movement agents to do simulation in environments. And that would allow you to know which areas of the city has been more used. And again, this is really useful as a way to evaluate the design of a city or design of a master plan. And again, more recently, there has been lots of research in reinforcement learning agents where you can use these like learnable agents that, because in the past, I think agents was very much you have a single behavior. But now with these kind of machine learning techniques, agents actually learn in real life. So rather than only using agents with like a constant behavior, these would be agents that has already learned how to navigate in cities. And maybe with the computation that is allowed nowadays, you can actually use these agents in a master plan to really better understand how people would navigate in cities. And again, this is some really recent work where they trained a massively parallel deep reinforcement learning agents to simulate these robots in this first in virtual space, but also in physical space. So in terms of future outlooks, I think there are two really important topics that I want to briefly discuss. The first is on long-term and short-term forecasting. So there's some research I did with some colleagues at the Turing and the British Antarctic Society, where we try to predict the sea ice extent in the Arctic. So I think these kind of techniques can also be used in the urban design process. So rather than trying to predict just so using these methods, you can also do long-term forecasting, but also nowcasting, like what is happening tomorrow, but what is happening many years from now. So these methods can, and I think these long-term forecasting methods are especially important when we know how cities are interacting with like climate change issues and so forth. And the second topic is related to neural architecture, and partly in like knowing Kate is coming to the talk, I had a thought and thinking on how architecture, on the importance of neural architecture. So these are like this is related to what Kate mentioned earlier on like which parts of the brain is firing in these kind of like brain scans. And I was wondering what kind of data science methods that I spoke of earlier can be used in these kind of like neural architecture kind of studies. And traditionally, these kind of neural architecture studies has been using like static images. Can some of these like advanced kind of like, I don't know, rendering methods, can they be used in these kind of field to better capture the environment when we are like scanning which parts of the brains are being activated? And I believe understanding the neural mechanism to why we design and where we design is related to the question that I think is really difficult to answer, the why and the causality of why we're making certain design decisions. And so I just wanted to end this really short talk or speculative talk I say here on the relationship on how data science is interacting with urban design, but also on some of the steps that I think could be looked at going forward. So I hope I was on time, but thank you very much. Yeah.
Thank you very much, Stephen, for the fantastic talk. Thank you so much. Super interesting. Quite a mix, a collection of techniques, completely fascinating.